neurons are able to maintain their integrity. Every part of the neuron is very important. It has a function in their communication pathway through an action potential or nerve impulse. And you know that neurons can be damaged. And you remember the difference between the neuron inside the CNS neurons versus the PNS neurons. The CNS neurons, when they get damaged, the injury is more than likely permanent because of our astrocytes. Remember that? You should know that when any cell gets damaged, they will release chemicals. And we will understand those chemicals more when we study the immune system. But when cells get damaged, they always release chemicals. And that's a signal. And in the CNS, you remember the astrocytes, you remember the neuroglia called astrocyte. When they detect chemicals, that's their signal. They start making scar tissue. We don't have astrocytes in our PNS, in our peripheral nervous system. So you compare your CNS neurons versus the PNS neurons. The PNS neurons, what is the key for regeneration of neurons? Very important is the presence of the Schwann cell, the one that myelinates the axon of neurons. Of course, if the cell body is the one that's damaged, it's very hard to heal. But if the axon is the one that's damaged, look at the way, I just want to show you again your oligodendrocytes versus your astrocytes. Okay, here, oligodendrocytes versus the Schwann cell. Both the oligodendrocyte, there's the oligodendrocyte, and here's the Schwann. So this is PNS neuron. This is CNS, your brain and spinal cord. You see that both this one, oligodendrocyte, they're the ones that myelinate the axon of the neurons in your CNS. And the Schwann cell myelinates the axon of the neurons in the PNS. You notice something? You look at this oligodendrocyte. One oligodendrocyte myelinates several axons. Whereas you look at this one Schwann cell, just one segment of the axon. Then that's another Schwann cell, that's another Schwann cell. Okay? So the fact that this one, several axons depend on one oligodendrocyte, number one, plus the enemy here being the astrocyte. That's absent here in your peripheral nervous system. So regeneration of damage in your PNS is more likely compared to damage of axons in your CNS. There are a few things that need to be fulfilled to ensure regeneration. Number one, as long as the cell body of the injured neuron is intact. Number two, as long as the Schwann cell is also not damaged. And number three, as long as the separation is no more than 3 millimeters, then regeneration is more than likely. Let's see how they regenerate. So there is the damaged axon. This one is here. You see, they're just going to highlight it. I'm going to go back to this slide right here. So there's the cut right here. See, there's the Schwann cell. See, the cell body of this neuron is still healthy. There's just a cut right here. This is what happens when we get, maybe there's an injury, okay? You cut this part. Cell body still healthy. Schwann cell unaffected, you see that? This distal stump, right, and the distance is no more than 3 millimeters. The distal stump will undergo degeneration, you see. And that degeneration is referred to as Wallerian degeneration. Right here, Wallerian degeneration. It will degenerate, but the Schwann cell is key. Just like a cast, when you have a fracture, there's a cast, right? Allowing the bones to reconnect. That's basically what the Schwann cell does. See? As long as the Schwann cell is present, it will reform your myelin again, allowing the injured axon to regenerate. Why is this possible? Again, the cell body is healthy, right? Your Schwann cell is there, and the distance is no more than 3 millimeters. Then it will regenerate. That is not a possibility in your CNS. You require the Schwann cell. Okay? Do you have any questions so far? No questions? So break for 5 minutes. We start with our CNS, the brain. We're just going to do introduction to the brain very quickly, and then you use the rest of the time period to study for your bone lab exam. Okay?